Hi, my name is Vannya Maheswari. You can call me Vanya. I'm a student at Dian Nuswantoro University, Semarang, majoring in Informatics Engineering. It is an honor for me to be able to complete the paper conference and to be able to take part in Isemantic 2020 in the middle of the COVID-19 pandemic. In this session, I will briefly explain my conference paper entitled Study Analysis of Human Face Recognition Using Principal Component Analysis. There are 6 points that I will explain here. Point 1, introduction. Point 2, explanation of PCA. Point 3, explaining research method. Point 4, discussion and analysis. Point 5, comparison and discussion. And the last point, conclusion of this research. In introduction, first, why choose face recognition? I choose face recognition to be the topic of my research because face is an identifier for everyone. Human face generally have their own characteristics and also have their own uniques, include even twins. These uniques can come from the shape and layout of the face, such as eyebrow, eyes, nose, lips, and others. This makes the human face an interesting research topic and objects of detection of recognition system. Second, what is the face recognition? The face recognition system is one of the biometric technologies that is continuously being developed because it is needed to facilitate activities such as identifying someone, search for someone, attendance machines, and even being applied to the security sector in order to grant access. Face recognition systems have many methods. One of the most popular methods is Principal Component Analysis, or PCA. PCA is a linear technique that functions to project data in the form of vectors that have high dimension onto vectors that have lower dimensions. So, PCA works by identifying patterns in data and then expressing the data in other form so that it can be conclude that similarities of difference between patterns. In the PCA method, there is an agent-based algorithm that is tasked with doing how to decipher the relevant information for a face image and then convert into a set of codes that are the most efficient. Then, the face code is compared again in a database consisting of various code face samples. Next, I will explain the reason why I choose PCA method in my research. Surely you will have many questions why this research used the PCA method, right? Although the PCA method is actually a facial recognition method that is often used. Based on the research result that I have read and searched before, I can conclude that the performance of agent face is very unique because it has different performance for each dataset. This can be proved by randomizing the context of the data testing and training data based on training data from previous research, and the results obtained are different for each person. Therefore, the study tries to test using a personal dataset to find out what level of accuracy is obtained. Point 2, Principal Component Analysis. Based on previous explains, one of the PC algorithm is eigenface. Here is a further explanation of PCA and eigenface. PCA technique is used to reduce information that a big data from face image without removing information on a face image. The eigenface method does how to decipher relevant information from a face and then convert it into the most efficient set of code. The agent phase method is in PCA is usually used to reduce a set of dimensions so that the new based on coordinate system can describe a model specifically based on that collection data. Research method. In making this conference paper, I used three-step research method. First, data gathering, processing and normalization, face recognition using PCA. Data gathering is the data in the study use private data and public data from Javi and the Yale database. Then preprocessing and normalization. The process of the preprocessing and normalization is done on a private dataset. This is because photos are taken selfie with various cameras. Face recognition using PCA. At this stage, the image dataset is extracted from facial image feeder. Data gathering in this research use private data and public data from Javi and the Yali database. Private data collect came from 20 people consisting of 10 male and 10 female, where photos were taken by a selfie with smartphone. The number of personal data sets is 400 images, which in the dataset are preposed and normalized data. While the data from Javi contained a total of 200 images and were taken from 10 Japanese women with 7 different expressions, which are consistent of 6 basic expressions and 1 neutral. The dimension of the Javi dataset are 256 times 256 pixels. At Yali, the database contains a total of 165 images of 15 different people, named 14 men and 1 woman. Each person was sampled 11 times with different expression. Next, preprocessing and normalization. The original image with RGB formats is done by cropping, resizing, and color conversion to grayscale. The cropping process is done in the face area with a ratio 1:1 to the length and width of the image. The resizing process is then continued to become an image 256 times 256, and finally, the image is converted to grayscale image and saved in TIFF format. Next, principal component analysis. At this stage, the image dataset is extracted from facial image feeder. Feature extraction is a process used to obtain effective information and serve to distinguish the face of the people who are different from the face image that has been normalized before. Point 2, the next step at this stage is to divide the image into 2 data groups, namely training and testing. The training data used is more than the testing data. In the personal dataset and Javi, it uses 15 training data per person, while in Yale 6 training data is used, and the rest of the other images are used as testing data. In the recognition step, the Euclidean distance calculation is used to compare the testing image feature with the training image feature. The training image feature that has the close similarity based on the Euclidean distance is chosen as the result of recognition. Accuracy measuring and analysis. Last step, the calculation of accuracy, meaning the results of recognition both in the private dataset and the two public datasets. Further analysis of the result is done. What things affect the effectiveness and optimize the recognition process? Result and analyze. Based on this picture, you can know that the left picture is the sample recognition results are correct, and the right picture is the sample recognition results incorrect. You can see this picture, and this is the results of an analysis. In the left table, recognition results of private datasets with 20%, and the right side, the recognition results of private dataset glasses percent. Accuracy in private dataset using 20% are 79%, and accuracy of glasses percent average 82%, and recognition results of the private datasets no glasses percent on the left side with 86%, and the right side recognition result of the private datasets mixed glasses and no glasses 50%, and accuracy average 85.33%. Then, this is the results of Javi dataset and Yali dataset. In the left side is Javi dataset with accuracy 100%, and the right side is Yali dataset with 85.33%. Next, comparison and discussion. This is the result of previous research which also used the Javi data. Comparison and discussion. This is the result of previous research which also used the Javi and Yali dataset. Then there are the results of my research. And then conclusion. The PCA method is proven to have the most optimal accuracy if all images are taken correctly and normally, without attributes and with the same background and lighting levels. This is evident by the recognition results in Javi dataset that reach 100%. Facial expression and gender are factors that do not really affect the PCA method. And the last point, the other factors that are more influential are the number of persons or class, the amount of training data, the use of attributes in the face image, and finally the lighting and background factors. Thank you. Any question? You can find me at Instagram Vannya Maheswari, email vanyamk@gmail.com. Thank you for watching and see you.